Welcome back, dudes. I hope you are all fine. So let's continue with our series on object-oriented programming in Python. So let's close this file. I'll create one more file for you. Okay, I'm using Visual Studio Code for your reminder. So I'll save this file. So I'll save this as code2. Fine, that's how it works. So I'll clear the output of my previous file. You just say clear, it will clear the output for you. That's it. Fine. I'm using terminal here. That's my I think Windows PowerShell, not Python. Okay, Python terminal. Fine. So in this, what I'm going to do is I'm going to use, I'm going to apply my knowledge in object-oriented programming to define a class called as complex numbers. Complex numbers, and I'm going to create a complex number like that. I'm going to do. You know what are complex numbers, right? I assume that you know already. So complex number will have a form of x plus iy or jy, to be more precise. Here it is there. Well, let's say iy because that's going to print iy only. So let's say iy. Fine. So x equals to x plus iy, right? So that will be like that. So yeah. So you have a real part and you have an imaginary part there. So a real part is x, imaginary part is y there. That's so that's the basic form of a complex number. So what I'm going to do is I'm going to create a class of complex numbers, and inside the class I'm going to have some methods, okay, from default methods. Okay, let me do that, okay, so that you can understand. So in this class, in this lecture, we are gonna define our own methods. Instead of using init only, we are gonna define some more methods. Like, so let's do that. So let me say class complex numbers. Let me name this like this: complex numbers. Put a colon. That's how you can define a class. And after that, I'll modify my constructor, which is def underscore underscore init underscore underscore, right? So I'm gonna get three arguments. One is self, another one is real, and another one is imaginary. So I'll say img. So when I say img, it's not image, it's imaginary. Fine. So I'll say self dot x equals to real and self dot y equals to imaginary. Again, I hope this will not confuse you. You may be clear with this in the previous videos. Like, so I'm getting two arguments here, say real part and imaginary parts. I have to get, whenever I create an object, I have to pass two arguments. One is my real part and imaginary part, and this will get the real part will be stored in x and the imaginary part will be stored in y attribute, and using this object you can actually access. So x, y. So how I'm going to print my complex number? It's very simple. Let me print a number alone, okay, so that it will be more. So let's say I'll put a placeholder there, say plus, I'll put again a placeholder into j, right? That's how we can create a complex number. Fine, that works. Self dot x and comma self dot y, or I have to use dot format here, I'm sorry. So dot format. Fine. So what it will do, I hope you know that. I assume that you know here because it's the basics of Python. So first the placeholder will have the value of self.x. Self.x will now have the value of real value that we are passing. So that will be stored to self.x, and first placeholder will have self.x. That's fine. And second placeholder will have self.y. And what will be printed, if I say 5 and 2, 5 is my real value and imaginary part, okay, is my 2. So 5 will be stored in real and 2 will be stored in imaginary. 5 will be assigned to self.x and 2 will be assigned to self.y. And if you use self.x and self.y here, 5 plus 2j, first placeholder will have 5 and second placeholder will have 2. So it's 5 plus 2j. Fine. That's how we're getting print. Just for understanding, it's printing that out. That's it. Okay, let me close. That's how you can define a constructor. We have done that, and you can, it's optional, if you are actually defining a constructor or not, it's actually optional for you. After that, let me say def and let me define one more method called as add. Okay, I'll call it as add, and whenever I say add, it should add two complex numbers. Fine. Okay, it should add two complex numbers. Okay, let me talk about this later. Before that, I'll do one thing. Instead of doing this in our constructor itself, let me define one more method for you called get number or get complex number to actually print whenever I call this get complex number. And again, this is not a magic method, you can see is just a normal method I'm defining using def keyword. And whenever I call this get complex number, that printf statement should be executed there. Will include that print statement here. And by default you have to pass one argument, say self. That's it. You need not pass any other argument because this is not going to get any argument. Whenever I call this method, that should be printed. That's it. Okay, I've been included this. Fine. I hope I'm making sense here. I'm just remove the print statement from the init method, the constructor method, because I don't want it to print whenever I create an object. Okay, whenever I create a complex number, here it is creating a complex number, right? We have a class of complex numbers, and our object is, object can be any complex number. So whenever I create an object, in other words, whenever I create a complex number, I don't want it to print. Okay, only when I call get complex number, it should print that. That's why I'm including print in some other method. I hope I'm making sense. So that's how. Let's come to main method. Let's get back to your indentation. Get off your indentation. You will be back to your main method. Okay. So main method, here let us declare a complex number. Let us create an object of complex number. In other words, let us instantiate the class using an object called. I'll name the object as, say, complex one. Any that's complex number one, it means complex number one. And I have to call the class, right? So I have to call the init method by using the class name. So you have to put the class name. That's how you create an object, right? Object name equals to class name, and you have to pass two arguments. It shows here. Okay, whenever I put a tab here, not tab, control space, I hope. Yeah, you have to pass two arguments here, say real and imaginary part. Real number is 10 and imaginary is 12. Okay, you can see we got it's showing that we have to pass two parameters. So real is 10 and imaginary is 12. I am passing 10 and 12, that will be stored here. Fine, that will be assigned to that. Okay, fine. That's how we can create a complex number. Let me run this code. Let's check what happens. Nothing will be executed. You can see we got nothing because this will be printed only if you call this method. Okay, now how to call that method, let me tell you that. Okay, so I have told you so many times, only using your object you can call your method, right? I got an example in the starting classes of this course. I got an example actually. Your family does not do anything. It's actually the objects inside your family, like mother. Father is watching TV, mother is cooking something. If you say my family is watching TV, that is actually wrong. The family is a class, and inside the family we have objects like you, family, you, your father, mother, like that. Okay, so you're all if I say my family is a class, and I'm an object of my family, right? So that's why, that's all. I can study, I can watch TV. That's actually executed by an object, right? So I am executing the process of watching TV. I am executing the process of watching series, TV series, or some web series. So object can only execute method. That's the point I want to insist here. Only objects can execute methods, right? So I'll use my object, say complex number, complex one. So that's my object here, complex one, to execute the methods. Let me call the method get complex number. I'll put round basis. That's it. That's how we can bundle object and method. Okay, so you have to use an object dot and method. That's how we can call the method. So now this method will be called, and you can see we have self here, which refers to this complex one. Fine. You can see we got output 10 plus 12j. Fine. So because it's getting printed, right? So that's prints output. I can create one more complex number. Say complex 2 equal to complex numbers. I'll say 15, 20. I'll say 15, 2. Okay, 15 minus 2. Let's see what happens. Okay, nothing will be different. Let's see. 15 minus 2. 15 is my real part and minus 2 is my imaginary part. Okay, I'll use the object complex 2 to call the method get complex number. Okay, fine. And let's see what happens. You can see we got the output 15. Yeah, this is the problem here. 15 plus minus 2j, because our statement is like that. Okay, so what I'm going to do is I'm going to modify this statement now. I'll say in brackets I'll put, that would make sense in some cases, but it's a better way to use any other formatting of printf if you want. Fine, that's how it works. Or you can use an if statement to check whether let me do that for you. let me check whether if self dot, again you have to use self keyword whenever you access an attribute, say real or imaginary number, you have to use the self keyword, right? So self dot y, if it is less than 0, meaning it is, if it is a negative number, then what you have to do, this is print statement, let us remove this, let us put it in here. Like if it is a negative number, you put minus j, you put nothing, because there will be a minus, there itself you have a minus, you put nothing, fine. So if it has a, else if it is a plus, if the positive number, print plus format self.y. That's how it works. So let's run this code and check what happens. You can see we got the output, say 10 plus 12j and 15 minus 2j. So what happens is we have included one more condition, say self.y, that is actually referring to our imaginary number now. So imaginary is, if you say, if you pass a negative imaginary number, self.y, if it is negative, which meaning it is less than 0, you are just printing it. You are neglecting the plus here, and by default that will have a minus. You are actually neglecting the plus here, and you, by default it will be having minus, and that is getting printed like this. So 15 minus 2j, fine. And else if it is a positive number, then you put plus, because by default it will be not having plus, explicitly, right? You have to mention that. That's why I'm putting a plus. That is getting printed 10 plus 12j, it's printed as 10 plus 12j. So for each object, you can actually print your complex number like that. So let me create one more method. Okay, let's talk about okay, that's how you can create your your own method, fine. Let's talk about magic methods for a while. So we have talked about only one magic method, right? So init, fine. We'll talk about another magic method. Say for an example, I'll ask you a question, okay? Leaving these behind, like not talking about oops, let's ask him a question, right? Basic question, like, so when I say a equals to 5, b equals to 10, I'll ask you the value of a plus b. What you will say? It's actually very simple, right? Pretty straightforward, right? So a equals to 5 and b equals to 10. If you add that, a plus 5 plus 10 will give you 15, sure, no doubts. Okay, that's fine. But the point here is, how it is actually doing. Fine. Whenever I'm saying a plus b, what is doing inside? Okay, what is internally acting inside? So here, if in objects, say for an example, this is a variable. So again, this is an object in Python, no doubts. If I say I have to add two complex numbers, say complex 1 and complex 2. If I, okay, complex 1 is some number, let's assume that some number, and complex 2. If I ask you to add these two numbers, like complex 1 and complex 2, what will happen? So you have to define the methods. You have to define a method for that. And the different point here is that the method name should not be insisted here. To understand it clearly, let us say we have one method here, get complex number here, and to call the method you have to use your method keyword. Okay, so I mean the method name. Okay, method name, you have to use the method name to call the method, say get complex number. But here in special methods or magic methods, you don't need to use the name. Okay, so for an example, it's in init here, and we are not using any init, right? We are not using init here. By automatically it gets called whenever I'm instantiating the class using an object. Automatically it gets called. That's the specialty of super methods, sorry, magic methods or special methods. So this is our own methods, so user defined methods. Again, everything is user defined. This is normal methods. So you have to use the method name to call the method, right? To get complex number is the method name here, and you have to use that to call the method. That's perfectly fine. But in special method, you don't need to. For example, if you want to add two numbers, okay, if you want to add two numbers, let me remove this. Okay, if you want to add two objects, if you want to add two objects, to be more precise, if you want to add two objects, you have to use your magic method called as add. I hope we have a magic method called as add or some. It's adder, okay. You have to use a magic method called as add, underscore add, and underscore like that. And if you have to pass self. By default, you have to pass self, no doubts. Fine. So fine. So now, if you, okay, let me say pass here. Let me define it in a while. Okay, let's not make it empty. Let's pass something and let's define it in a while. No problem. So if you want to call add, you can just do like this, complex 1. You can use two objects, complex 1 plus complex 2. fine, and this will work, which means when I say complex 1 complex 2 plus complex 2, you just note the plus sign alone. Okay, when I say complex 1 plus complex 2, just note the plus sign alone. If you execute the statement, it will call the underscore underscore add method. That's why it is called as magic methods. I'm not mentioning as add here. If I say plus, this will definitely call this add method. That's the speciality of underscore underscore. Fine, it's definitely called the add method. Okay, let me execute this and show you. Say I want to add two complex numbers. Fine, so okay, I want to add two complex numbers. Self super. But the confusing point here is, I'll just move the statement. The confusing point here is, self will refer to only one object, right? But if you want to use add function, add is nothing but a binary function. So binary method, it will take two arguments. If you can add only two numbers, right? Think of like that. You can add only two objects. So if I say complex one is an object of, let's say complex one is an object of complex numbers, and complex two is again an object of complex numbers. And if you want to add these two, you can do that, no problem. You can do that. And complex one plus complex two, if I pass like that, self will refer to only one object, right? I make any sense, I hope. So complex, if I say a comment here, complex 1 plus complex 2, I'll say, if I told you, if I say plus, this method will be called. Okay, and that's a specialty of this magic method. That's fine. If I say self refers to only complex 1. So what about complex 2 here? You have to refer that also, that then only you can add that, right? For that you have to use other keyword. Fine, other will refer to the other object. Okay, so you have two objects here, complex 1, complex 2. If you want to, you have to use called as other keyword. Fine, okay, that will work. Okay, let me add these two complex numbers. It's very simple. Self dot x plus other dot x, right? You have to add the real parts. Let me say this is adding the real parts, and you have to store it somewhere, right? Let me store it in something called as some attribute, and which will not refer to any object. So some temporary variable, to be honest. It will not be referring to any object. I'll just return it. Okay, so I'll say a equals to, fine. So a will now add the sum of the real parts. Okay, so self dot x will refer to the real part of complex 1, and other dot x will refer to real part of complex 2, because your self keyword is now referring to complex 1, other keyword is now referring to the other object, that is complex 2. Fine, and b equals to self dot y, that's your imaginary part, and other dot y, because we know our attributes are x and y. Fine, so you can use that anywhere. Fine, we have used it there, and we have used it here, and we are using another method. So that's attribute is common for the class. Fine, it's a class attribute. So x plus y, and I'm going to return a comma b. Fine, and in Python you can return more than one variable. This is not possible in C, C++ or Java. Fine, so you can return more than one. I'm returning both real and imaginary, sum of real and imaginary parts. Fine, I'll say complex 1 and complex 2, and this will definitely do for me, but I have to get that values, right? So for that, what I'm going to do is I'm going to just print the value. That's it. Print what it returns. Okay, right now if you don't understand this, please wait and let's analyze the output to understand it in a deep manner. Fine, let me trace the code again. No problems. Fine, so complex 1 plus complex 2, and again I'll say okay, let me print this, and let's after that we'll modify it. Okay, fine. Okay, let's modify it now itself. Okay, complex 1 complex 2, this will return a tuple pair. Okay, this will definitely return a tuple pair, no doubts. So I'll store the tuple pair at somewhere. Let's say I comma j equals to that. I comma j will confuse you. I'll say real and imaginary, and this won't give you any warnings. Okay, because real imaginary is specific to this function. Don't confuse this with this. So if it is confusing you, let me use some other variable name, no doubts. I don't want to confuse you in any case. Okay, fine. Let me say x a and a comma b itself. That would make sense. Okay, I'm returning a comma b, which means I'm storing something, and storing the sum of real parts and storing the sum of imaginary parts. I'm returning those two as a tuple pair. That's why I'm getting that as tuple pair here. That's also a comma b. That's not a problem. Fine. So this a comma b is different from this a comma b. Fine. And if you are confusing, let me say it is a1 b1. Fine. Okay, this, let's stick with this. This is final. Okay, a1 b1. So okay, I'll explain the execution later. Let me print here. I'll say yeah, I'll put a placeholder, and again I'll put a plus, again I'll put a placeholder. Fine. And I'll say dot format. I have a tuple pair now, which is sum of the two complex numbers. Fine, I have the tuple pair, say a1 b1, and I have to include that in format, say a1 b1. That's it. Fine, you are not referring to any object. They're just variables, right? A1 b1 just variables. You can print that like as like this. Okay, let me run this code and check. Before that, let us comment these and all, because we don't need that actually. Get complex number. I'm passing 10, 12, and 15 and minus 2. Guess what happens? So this should return, complex 1 and complex, this should return 10 plus 15. So, 10 is the real part here, 15 is the real part of the second complex number. If I add these two complex number, complex 1 and complex 2, this will call this method add. And self.x will be 10, because self refers to complex one. I told you self.x will be 10 and other.x will be 15. So those two will be added like 25, and that will be stored in A. Self.y will be referring to 12 and other.y will be referring to minus 12. Those two will be added and that will be stored in B, right? So I am passing the sum of a tuple pair, the sum of the real parts and sum of imaginary part as a tuple pair. That's the exact result of the addition of two complex numbers. Fine, I'll print that. You can see we got output 20. I forgot to put J here, sorry. I'll just clear this. You can see we got output 25. I just clicked the run button twice, so that's why it's getting twice. No confusion. So 25 plus 10J, that's the answer it given. Let's check. 10 plus 15 is 25, so 25 will be stored in A. 12 minus 2 is 10, that will be stored in B. So it returns 25 comma 10. Okay, so you are complex 1 and complex 2 will return, if you use this statement, will return 25 comma 10. Okay, will return 25 comma 10, and I am storing that in a tuple pair. Okay, A1 will be having 25 and B1 will be having 10. So I am printing that 25 comma 10 in some format which I wanted. So that's the format is getting printed, 25 plus 10J, using this placeholders, right? So the point here is adding real parts, adding imaginary parts, returning as a tuple pair a comma b. That is sum of real parts and sum of imaginary parts. And one more point here is you are not using the name add here. You are not using any add here, just using plus. That's the magic here. If you just pay plus and if you if you use dander like underscore like this will be automatically called, and that's called magic method in Python.